So in this video, I wanted to go through in a little bit more detail some of the other things that you can do with the Hugging Faces Transformers Python libraries, particularly their more simplifying pipeline approaches to using the tool for AI-based work. I'm going to go through some of the other things that we can do with it in 1 minute, but I wanted to pick up on something that we didn't have time to do within our workshop series. So we use Transformers image classification approach to provide a label for a very simple image. And so if you recall, we used it on this particular image of this golden retriever puppy, and the approach was able to successfully determine that this image contained a golden retriever. And we also did it with a few other objects as well, other images as well, including an image with a poodle. But one thing that this type of image classification approach doesn't do so well at is trying to determine what is contained within an image like this. And so, for example, in this case here on the right, we have a cat and a dog. And if we try to do image classification on it, we don't necessarily get good labels for each of the individual things featured within this data set. And so we get an image for a Chihuahua, which may not be completely incorrect with this dog here on the right, but you can see that none of the labels provided by this image classification approach give us some form of cat-based label. And so this is one of the kind of general limitations of using image classification. And so if you were trying to do work on a data set like this with images that had a lot of different I guess for lack of a better word, subjects within an image, you can use a little bit of a different approach that is also available with Hugging Faces Transformers pipeline, and you can use object detection. And it works quite well, and the approach to how you do it is it's a little bit different. And so you're not necessarily going to get the specific breed of this dog and the type of cat that we might see here. But essentially what object detection will do will look at your image using an AI-based approach and put a kind of bounding box around what it thinks a object might be. And so in this case, when we're done, we will have a better idea that this image contains both a cat and a dog, and we will have a sense of, where they are within this actual image. So let's just quickly go through how you actually do it. And it's, relatively similar to all the other ways that we have used Transformers thus far. And it's actually quite similar to how we do image classification. So we still import the two libraries required for this type of classification. And so again, always you have to do the pip installs for them each. And so this essentially allows you to use the library. And in this case, we're sticking with Google Colab, but you would have to use an approach like this if you had installed Python on your individual computer as well. So we need to install Transformers, and we also need to install a bit of a image manipulation library as well. And then once we have installed both of those libraries, we want to import the pipeline functionality from Transformers. So we will press play and run this code block. And it takes a little bit of time because it has to install, download the library to Google Colab. And in this case, it's actually downloading two different libraries. So depending on the speed of your internet, this might take a little bit of time. But whenever you see that kind of this stops kind of thing here, this button here, stop rotating, it will be complete. You'll also see a little number amount of time it took here on the left-hand side as well. So it is almost done. You can follow along as it installs things. And whenever, as we said, whenever this stops rotating, it will be complete. Should be finished shortly. And so now it's done. And that whole process took 32 seconds. And so now the libraries are available to use. We've installed both libraries, and we've also made them available using an import statement to use within our code. Now we want to instantiate our library as we did before. And to do object detection, the formatting is a little bit different. And all of these, this code is available within the Transformers website. But essentially, it's a similar type of approach. We just do, we define a variable called object detection, and then equal, and then we we always have to call the pipeline, and then, whatever the word you put in here, the string you put in here will depend on what pipeline you're trying to use. And so in this case, we're trying to use the object detection one. And so we'll just run that. So Control Enter will also do it. And as before, it's going to download a couple of pre-trained models. This particular object detection one isn't quite as large as our image classification one. It was 167 megabytes. We've used the default object detection model. There are some other ones you can specify, but this will work fine for our needs. So now we have instantiated our object detection model, and we actually want to do something with it. So we have to, as we did before, upload our image that we want to do detection on. We will open up the little file section of Google Colab, and then we will select it. So again, the dogs and cats image, and we will just OK. And again, if you were to open up this image or this Google Colab notebook a different time, you would have to re-upload this image. And so essentially when the runtime gets stopped, you need to re-upload it again. So if you ever didn't happen to see the file, let's say if you were to work on this tomorrow and you didn't see this file here, you would just have to do the same process again. So the image is now available in Google Colab. Now we just want to run the object detection on it. So we'll do another code block, and then we'll instantiate another method. So in this case, we're going to call the object detection method that we declared before, and we're going to perform it on our dogs and cats image that we just uploaded, and then we will run it. Again, this sometimes takes a little bit of time, but not quite as long as before, so 5 seconds. And then finally, so now we have information from our object detection, but we want to print it out to actually see it. So we can just do that simply by typing print and then object detected. You can just click on it as well if you don't want to type it out. And then we can run that. I'll remove this one. There we go. So I'll run this. And then essentially what we get back is a collection of the objects that this approach identified within our document. And so you can see here that it believes with a 90% accuracy score that it has found a cat. And then it also provides some coordinates for a bounding box, which can be helpful if you want to identify where that actual cat is within your image. And it also has identified that there is a dog in the image as well. So again, with a high level of confidence. And so again, 99% confidence. And has also provided us another bounding box for where that is. And so the one thing you will notice with the labels returned here is that they're far more generic than what we would have got with our image classification approach. So we got a specific breed of dog when we did it on our golden retriever earlier. In this case, it's just more generic. We have cat and dog. And there's a variety of different image object detection models, and you might get a little bit more detail depending on the model, but this is a relatively small one, a quick one to work with. It's only 167 megabytes. So you get a little bit more of a generic label for the objects that are determined. But you can still see that now with the object detection, we have successfully found that this image has both a cat and a dog within it. So just to note, one of the interesting things that you can do with those actual coordinates that are provided by Hugging Face transformers is with a little bit more work, and I won't go through it here today, but you can essentially make a visualization approach of what your results are. So we can see here in both of these cases, and in these cases, these two images were created with the Google Cloud Vision image detection model, which is another useful cloud-based approach to do this type of work. But you can see here that given that kind of similar information that I was given, I can create a kind of bounding box around where the objects were that it has detected. And this can be useful if you want to kind of manually go through your data. You can have a better sense of, whether your model is working well or not. And so in this case, it has determined that this is a flag, and there's a couple of different versions. I've included the label and also the confidence score of it, what it thinks it is. And you can see it also determined a whole bunch of people down here as well. And the one on the right is very similar. It works a little bit better because there's it's a far less busy image, but you can see that it recognizes the flag, and it can also recognize the tire as well of this truck. It's interesting in that in this case, it didn't actually recognize the truck. But again, you can using those bounding boxes, you can get a little bit of a sense of how well your object detection approach is working. And you may have, you may find from these results that you have to kind of tweak things a little bit or potentially use a different model. But it's useful to have both, not just what it has found, but a bounding box surrounding what that thing might be. So there's a whole bunch of other things that you can do with Hugging Face Transformers pipelines. They're all listed here on their website. I won't go through them all, but for example, you can do speech recognition, you can do audio classification, you can do a little bit of conversational chatbot work with it as well. There's a rather interesting question answering technique as well. A few things, and I'm sure as the tool develops, more and more pipelines will come into place as well. But I just wanted to give you one more example of what you can do with one of these pipelines, and we'll do an AI-based translation as well. So again, lots of great pipelines using Hugging Face Transformer, and the nice thing with these pipelines is that they are relatively simple to use. So we'll just do one more example of how you can use the Transformers pipeline to do simple translation between English and French. So as before, we will just install the library and then import the library into our Google Colab environment. And again, it takes a minute as it downloads. Well, maybe not a minute, perhaps about 30 seconds. So it downloads them. And again, if you were doing this on your local machine, you would use a similar approach, but you just wouldn't need the exclamation mark before the pip. It is almost complete. And again, when this stops rotating, it will be done. You can't do anything with these other libraries and other code blocks until this is complete. So it took 32 seconds, but it is complete. You'll see it's complete when it has a little check mark in the time there. So now that we've done that, we want to instantiate our model. And right now we're going to do a translation between English and French. And again, depending on the translation you're going to do, this string will be different. One of the caveats is that it doesn't do obviously a lot of languages yet, but hopefully that will expand with time. But we are essentially going to take English to French. We will just run this low code block. And as before, it's going to download some language models. It's actually going to use that T5 base model that we've used in a couple of other instances at this point. And it takes a bit of time because it is almost 900 megabytes. There we go. So that was complete, took 20 seconds. So now we want to do our actual translation. And it's similar to what we've done before. So we just call another variable or create another variable called translation, and then do an equal sign. And then we use this that we created before and just pass in a sentence that we want to translate into French. And then we print it. Relatively simple sentence. And you can see here that we get the corresponding translation from this sentence to French. And the one thing you'll notice, it returns a list with and this is a dictionary item. We didn't go through this in the workshop series. If you wanted to access just the translation text, there's a little bit of a formatting that you can use for that. So you would, since we called it translation, you would do translation. And this technically is a list with only one item. So if we want to access that first item of the list, we have to use the square brackets with a 0 inside it. And then because this is a dictionary, we want to access a value of a dictionary, we have to do another set of square brackets and then put in this first dictionary value here. And so if we print this out or run this now, you can see that essentially we'll get just the text, not the other data that is being used as part of it. So again, just another simple example of what you can do with the Hugging Face Transformers pipeline. You can do a simple AI-based translation as well. In this case, we did translation from English to French. So Hugging Face Transformers obviously isn't the only library or Python code base that allows you to do AI-based work. One of the great things about Python is that it's used by a significant amount of people, and because it has a significant user base, people are creating these really great tools. And oftentimes these tools and these libraries will simplify aspects of the work that we want to do, particularly within the AI space. And I'm not going to go through all of these in detail because they're in some cases quite they do quite a bit of things, but I wanted to mention at least a couple of different libraries that you can use to do AI-based work in Python. And one significant one is the scikit-learn toolkit, which again it does a whole bunch of things, and you can kind of see them here all listed within their page. Another common machine learning based Python library is TensorFlow, and again this is available to do work on your own individual machine. Another one is PyTorch as well, so it does again a lot of really great work if you want to do machine learning and don't necessarily want to redo the entire wheel of how you create something. One further one is Keras as well. Keras is supposed to be theoretically a little bit simpler. All of these tools often do similar work, and some of them actually rely upon one another, but just, I guess, know that they exist and know that they're available to simplify, to a degree, simplify some of the work that you might do related to artificial intelligence using a tool like Python. Not quite as simple as using the transformers pipelines, but if you wanted to look into things that would be the next step once you're a little bit more comfortable with Python and machine learning approaches, these libraries might be good ones to start taking a look at. Another one that isn't exclusively AI related, but is within the domain of AI is the Natural Language Toolkit, or NLTK. And often I will use NLTK to prepare text for using AI-based natural language processing approaches. And it does a whole bunch of things. We won't go through all of them, but oftentimes you will have to tokenize text before you do some type of AI-based work with it, and NLTK does that automatically for you. And that's essentially splitting up sentences and words into individual tokens. A whole bunch of things that you can do. You can do lemmatization and other things with Natural Language Toolkit. And it essentially really is a really great tool that helps prepare your data to be worked on. If you're going to do natural language processing tasks, you often have to do some work to prepare it beforehand, and NLTK is a really great tool for that. Another kind of Python library that I'm consistently using, mostly within the domain of getting data ready for either AI work or other computational work, is the Pandas tool. I think of any tool that I have used after I've learned Python, the one that I have used most is the Pandas library. And it's really great because you can really programmatically alter and do some work with your data. And it's a way to kind of wrangle and alter your data in a way that is a little bit programmatic. And so you can do much of what you do with Pandas using Excel or using SPSS or other statistical software. But at least from my perspective, I've always found using Pandas, once you have a better understanding of Python, far easier than using some of those software-based approaches. So to give you a little bit of a sense of what Pandas can do, I wanted to show you a little bit of code. And so essentially, as a researcher, I'm working on some research related to some social media data. And essentially what I have done using the Twitter Academic API is that I have two lists of CSV files of user data. And so we have one here with a list of user IDs, username, and descriptions, and then another one that's in the same format. Again, user IDs, username, and descriptions. One of the challenges of often using computational approaches for research is that the data you get isn't necessarily always clean or isn't always in the format that you need. And so with both of these CSV files, because of the way that I was running the Twitter Academic API, I had to create two separate CSV files. I had to run these queries on two separate days. And if I want to do analysis on this work, I'm going to have to kind of combine them together, and I want to clean them up a little bit. And so I would ideally, you can see here that the text file is a little bit messy, and I want to get rid of something like new lines so that all of my information is on one line. Not necessarily required, but in my case, it would simplify things a little bit. Essentially what I've done here is that I'm trying to find do some analysis on the Twitter bios of individuals related to a specific topic. And to make that a little bit cleaner and make it easier to do some data analysis with, I'd like to get that all on one line. instead of having new lines kind of interspersed within that data. There's also some information here that was gathered that I don't really need. And so I can use a tool like Pandas to prepare that information. And I could do this using something like Excel or SPSS, but I find the approach of once you know Pandas to be far more simple. And again, Pandas is a big topic, but I'll just kind of show you some of what you can do with it. And so like we saw with some of our other examples, to first use Pandas, you would need to install it on your individual computer using pip. And then once you install it, you would have to import it. And so you just go import pandas, and then you will give it, you can give it a kind of an alias, for lack of a better word, so it's a little bit simpler to refer to, so it's not a long form here. And so what we've done was we've imported pandas, and we've also imported the CSV standard library from Python as well. And that helps us do a couple of things as well. So with pandas essentially revolves around data frames. And you can think of data frames essentially similar to what you would think of as spreadsheets. And so they're just kind of tabular data. So rows and columns like a spreadsheet. And so essentially what I'm doing in these first couple of lines here is I'm reading my two CSV files and saving each of them into a pandas data frame. And so then what I'm doing is that I'm going to concatenate those two data frames together. I want to, as you recall, have both of these output files, this output 1 and output 2, be one file altogether. And I can do that in Pandas by concatenating them together. And so essentially, to do that, I have to make a little list of my two data frames, and then I can use a command available in Pandas called concat to kind of merge them, the two of them together. And in this case, it's relatively simple. I didn't need to do too much altering of how this is, because I have both of my CSV files have a similar format, and so they're both essentially the same with different data. They have the same set of columns and rows. So you could do a concatenation, a more complex merge with data frames that had different columns. You could use some elements of one, some elements of another. It does similar work as you might do with databases, but in this case, I wanted to keep things relatively simple. My two CSV files have the same columns, and so it's relatively simple to concatenate them together. So now at this point, what I've done is created a third data frame with these basically consisting of these two data frames. And so then once I have all of my data together in one data frame, I can essentially remove those new lines. And so this is what I'm doing in this line here on line 11. I am looking at the concatenated users data frame, and within the description column, which you can recall is one of the three columns as part of the CSV file, I am replacing every new line that is found with an empty string, which will essentially remove them. And to do that, you have to add a couple of different attributes. You have to say that you're using regular expressions, and you also want this in place to be set as true so that the change actually occurs within the data frame that you're working on. If you don't put the in place in true, you wouldn't actually have the changes actually occur. So now this line has removed all of the new lines from our data frame within this specific column. I've also found that with this data set, I have a couple of, duplicate records. The way that I was collecting the data from Twitter means that I will have some users represented more than once within this data set. And so to get it a little bit cleaner, I want to basically drop any repeat users from our data set. And so again, there's a very simple command within Pandas that allows us to do that, and it's to simply drop duplicates. And you can base it upon a specific column. And so I want to drop any columns where there is a duplicate user ID. And I essentially want to keep whatever the last one is within the data frame set. Because in my case, it doesn't matter too much what the actual one that is kept. In some cases, you may want to specify, there's some other things that you can add here to specify, for example, the value that is highest or something to that effect. But in my case, it does not matter. I just essentially, if one user ID exists, I want to have one record for it. And so this line essentially removes every single duplicate user ID. And in this case, because I haven't put an in place equals true, I actually have to set the data frame to itself. And that's one of the benefits of using in place equals true. So I've done that with this line. And then finally, what I'm going to try and do is I ended up with some user IDs that essentially my data set was looking for users that had student or student in Spanish within the bio of their Twitter bio. And I was finding, for whatever reason, I was getting some bios without either of these terms within it. And so essentially what I'm doing with this line is filtering my data set to only include value or rows essentially that have student in Spanish or student in English within this description field. And so essentially all of those extra fields extra rows that don't contain student have been eliminated. And I've done a few other things here where any empty lines I wanted to be ignored, and I didn't want to worry about case as well. So I found when I first set up this command that if I didn't have it be case sensitive, if I had it, I've now set it up to be case insensitive, which meant I would get both student starting with an S and student starting with a capital S. Before I had this line, this attribute here, it wasn't. It was only getting the exact text that was matching here. So essentially this line will filter out every record that doesn't have the student or the student in Spanish included in it. And then finally, once I have this data set, this cleaned up data set where I've removed the new lines from the description field, I've removed any duplicate user IDs, and I've also filtered out any records that didn't contain student, I am then able to kind of very easily save it to a new CSV file. And it's very simple. You just call your data frame and then go dot and then _CSV. You give it the name of what you want the file to be saved as. I want to remove the indexes, which is a little number that can be put in the front of the CSV file. And I want a certain form of quoting around my different values. So I want any value within my data frame that is not numeric to have quotation marks around it, and that can be helpful for strings. And so that's a simple Panda-based Python file. So if I run it now using the Python interpreter, so I'll go Python and then simple Panda and press enter. Essentially now what has been created is this new file. So if I open it up, you can essentially, we now see that we have a somewhat cleaner data set. We have there are two outputs combined into one file. We have the new lines removed from these descriptions, so every single record is contained on one line. And we have filtered it to include only records that have student in French. We also have it filtered now by only having records that have either student in Spanish or English contained within our data set. So again, Pandas is a really great tool if you need to do work in preparing your data for use using artificial intelligence approaches. And again, these are just a small sampling of the different Python libraries that will help you do AI or other computational work. Again, as I've been trying to stress, one of the big advantages of a tool like Python is all of these pre-existing libraries that opens up, artificial intelligence and computational work to people that either have beginning or intermediate programming experiences.